Our last unit before we begin our study of trigonometry is on logarithms. And I know that normally you have seen a little bit about logarithms before you get to pre-calculus. I'm not sure if you have or not, but we're going to treat it as if you have not. And so we're just going to start from the very beginning. So a logarithm is just the inverse of an exponential function. And so if I have this as my exponential function, some value to the x power, that's just the same as y equals b to the x power, then whenever I find an inverse, I just switch out x and y. So I would just switch out x and y, and this is representative of a logarithm. But how do we solve for y? And that's where the logarithm comes in. That's what it's called. When I rearrange this so that I can solve for y, I'm taking the log of this equation, or the logarithm of this equation. And so all it is a rearrangement of the values. And so I'm trying to get y by itself, so y goes by itself equals, and then your log has a base on it. Log base b of x. And that's just how we rewrite it. So the y goes by itself, the b and the x on the other side. The b is the base of your logarithm, and then x, your value inside the logarithm. So we're just going to practice rearranging some of these today using that form. All right, so here is another one. They are giving us this equation, which is actually the same as the one above. It's just that instead of putting b, they put e. E is an actual value. E is just the natural number. So on your calculator, if you put in E, it will tell you that that is 2.718281828. It's kind of like a symbol for pi. E is just a symbol for the natural number. But anyway, I just rearranged this, so I'm going to have y equals e to the x. The y goes by itself, right? This goes by itself. And then over here, I'm going to rearrange, so the y equals L log base e of x. And I almost wrote it ahead of time. Log base e, because it is used quite often in applications, has its own name. It's called the natural logarithm because it's the natural base. So it is also written as log, or ln, of x. It's understood to be the natural log, or log base e of x. So log base e and ln x, they are the same thing. They're interchangeable. But again, it's just a rearrangement of the values. And so that's what's in this little table here, the boxed in portion. It's telling you that if you have log base b of x equals y, you could rearrange that to exponent form. B to the y equals x. Here, this is ln of x, or log base e of x equals y. So it would be e to the y equals x. These are always equivalent to each other. They mean the same thing. It's just that this one, with the logarithm, the y is by itself. We can solve for y. Now, if you see a logarithm that doesn't have a base, like there's no number written there, it just says like log of x equals 10. This is always understood to have a log base 10. So if there's no base written, understood to be base 10. All right, so all we're going to do is practice rearranging here. So we know that these are equal to some value over here. And instead of putting an x or y, I think I'll just put a box. So if I were to rearrange this back to exponent form, it would be 8 to some power equals 2. I'll skip down here to number 4 real quick. This would be 5 to some power equals 1. This is my box over here. 5 to some power equals 1. So in this one, this one is understood to be base 10, right? There's no base written, so it's understood to be base 10. So this one would be 10 to some power equals 1 over 10,000. 10 to some power equals 1 over 10,000. Same for this one. This one, though, is understood to be base e. So this would be e to some power equals 1 over e to the third. Now, we're going to go ahead and solve each of these. So in order to solve, we did this in our last unit on exponents. We're going to need equal bases. So 8 is 2 to the third power raised to some unknown power. I probably shouldn't have boxed that. We already have too many boxes. Let me undo that. We just have 2 to the third power raised to this unknown power equals 2 to the first power. Well, a power to a power we multiply. So this, and we can drop off the bases. So we'd have 3 times some number equals 1. So if I divide by 3, then I get 1/3. So let's just say this is an x. Solving for x is 1/3. I'll go ahead and put an x in for the rest of these. So here I need base 10. So this is 10 to the x power equals 1 over 10 to the fourth power. 10 to the fourth power is 10,000. To bring that up to the top, I have 10 to the x equals 10 to the negative fourth power. So x is -4. All right, for this next one, I have e to the x equals 1 over e to the third, or e to the negative third power. So x is -3. And this one, I can't make these bases the same like I did on the other 3 examples, but we should know that any number raised to a certain power is always equal to 1, and that power is 0. So this is 5 to the x equals 1. So x has to equal 0 because anything to the 0 power is 1. All right. So the goal here is to know how to rearrange them, and in your mind, the more you do these, in your mind you'll be able to do 8 to some power gives me 2. Well, how can I do that? Well, 2 to the third, I mean, it'll come to you, and so you won't have to write down every single step. And so hopefully you'll kind of see as we work through this unit on logarithms, and these will become a little easier for you. But for now, just rewrite them, and if you want to put an x here, you can, like 8 to the x power equals 2, and then you can solve. So we're going to continue with that same information where we just rearrange our logs. So this one is understood to be a base 10 because there was no base written. So 10 to the second power equals x squared minus 1. Let's rearrange. 10 to the second equals x squared minus 1. So this is 100 equals x squared minus 1. Add 1. We get 101 equals x squared. So then we would take the square root, and the square root can be positive or negative. For number 6, this is understood to be base e. So we have e to the second power equals the absolute value of x, and we know that the absolute value can also be positive or negative. So we have x equals plus or minus e to the second. And since this is without a calculator, we'll just leave it e to the second. We're going to leave number 7 for the last one. So let's go ahead and do number 8. This would be rearrange 6 to the second power equals x. So x is 6 squared, or 36. Now this one has a couple of logarithms, so it looks more complicated, but just one step at a time. So we have 6 to the first power equals what's inside here, which was log base 2 of x. But, and I'll put it over here on the left so it looks like all the rest of them. Now we just have a new logarithm problem, so we just rearrange it again. So now we have 2 to the 6th power equals equals x. And 2 to the 6th power is 64. All right, these last two are just calculator problems. So you can use Desmos or you can use your TI app. And we're going to put the left side in y1 and the right side in y2 and just solve. So here we are, left side y1, right side y2. I'm going to zoom 6 and take a look. So this curve here is ln of x. And you notice it looks a lot like the exponential function that we had. Remember, the exponential comes up this way, and here's my logarithm this way, and we know that exponents and logarithms are inverses, so they are symmetric across that line y equals x. So this is our first look at a logarithm. And then we have the line at 1/2. So we're just going to sketch that real quick. So we have our logarithm graph coming up, and then we have this line coming across, and all we're asked to do is find the intersection. So we're going to second calculate the intersection. And there we go. The intersection is at 1.649, comma 0.5, which is our 1/2. So x is 1.649. All right, we'll do the same thing for number 10. All right, so here they are. And also, I guess I should show you on the TI, both the log and the ln keys are down here by your number keys. So if you were having trouble locating them, that's where they are. So we've got log x equals negative 1.2. So let's take a look at the graph. There's our log, there's our negative 1.2. So we're going to sketch that. And we want to find our intersection down here. So second, calculate the intersection. You may have to hit that arrow key to make it recognize the graph. There we go. 0.063. So x is 0.063. All right, so that is it for our first lesson in logarithms.